Hey, good morning. Good morning, you all in India. Good afternoon in England. Good evening in California, my friends. And good night in bedtime in the East Coast. This is Ramananam Raju, and this is a live broadcast. We are talking today about the book I've written is called um, "Science is not a subject. Science must be a lifestyle." This book is so we are going to talk. One of the chapters in the book is called "Positron Emission Tomography." Is written by Paul Dirac. So I'm going to talk about Paul Dirac. I was let me bring that flip book on the my thing that one, and I'm going to share this. 1 second. Um, I hope I can. You see? Do you see that I'm sharing the book? No. Oh no. Tab. Chrome tab. Okay. Thank you. This is technology challenges. There's a entropy. It's called technology. More complicated it is, you get easier in one area, and then gets 10 times more complicated in other areas. That's what the technology creates. It where that's called entropy. So we're all facing that entropy problem. Okay, is technically challenging, and but we're solving. But this is a very interesting for medical people, particularly people who are in the radiology field. Positron emission tomography. I'm going to talk about Paul Dirac. So Paul Dirac is a there's a lot of tests. This is my book that what you're seeing. This book has a 150-page book you can buy on uh, on e-commerce platform, and you would be this has a really interesting stories, and that inspires a lot of innovations. These are the scenes behind the healthcare innovations from past to present to future, because doesn't change. Scientific principles remain. They're not like a technology today or Python tomorrow or React something else. So, but in the science, the scientific principles are constantly timeless. So here is the principles that behind the positron emission tomography PET scanner. As you know, most of the people who don't know, but I will explain what the PET scan is all about. Is to detect the PET scans are used to detect tumors and cancers. That's the only way you can get a functional design. It's not a structural. Structural is you can see the tumor and you don't know exactly how active it is, how so to find the functional aspect of it, you have to use a PET scanner. That's the only way you can find the functional aspect of the tumor, what stage it is at, and how active it is. That is only come to know through PET scanner. That's PET scanner. Full abbreviation is positron emission tomography. So we are going to talk about the story of proton, where the positron came from. I'm going to switch back to a little bit of a positron thing that is a positron. The story of the positron. I'm going to talk about it. So when the universe, this is strange, as you this positron PET scanner is related to the Big Bang theory and the universe itself. So when the universe was when the universe was created, the first Big Bang, there are two kinds of matter and antimatter were created equal amounts. They split into two. The matter and the equal antimatter was created. But the strange thing is, we don't know what happened to all the antimatter is. That's still a mystery. We don't know the address of the antimatter is. People think different theories. They think that is a dark matter and all those theories, but we don't know the exact address of the antimatter is. But we see the effects of the antimatter because when the cosmic rays come from those, so you see some of the positrons, going through our bodies, coming from outside. Um, but also we see in here in our earth the antimatter is. So antimatter was created. You can see through the bananas emit one positron every 75 minutes. We human bodies, because we are potassium 40 is a radioactive nuclide. When we consume it, we also produce a 200 positrons per hour. Actually, as strange as it sounds. But what is a positron? What is a electron? Is actually is an opposite of electron. Positron is an opposite of electron. If you have a when I say that evil twin, when I was talking about evil twin, is it's like something that analogy is that if you see in the mirror, in the person in the mirror is somebody is the same person as you are, but imagine that he is separate from you. And then but you never wanted to meet them, because when you meet them it's a destruction, because the matter and antimatter can, if they meet, they produce annihilation, and it produces a lot of energy. So that you don't want to do that. You don't want to meet your evil twin. But but that is a positron is basically opposite of electron. Electron is negatively charged, positron is a positively charged. So there is a matter also, anti-atoms. Hydrogen atom is, for example, nucleus is a positive nucleus in the center, and the electron is moving around. Um, and if you go into the antimatter hydrogen, anti-hydrogen, for example, it is a negative proton in the center, and the positive electron positron moves around it. So for purposes of principles of physics, it is all same. You can feel everything is same, except that they're entirely different charges, and they switch the roles. So you have to be. So this is invented by Paul Dirac. This is was the great scientist Paul Dirac find out. He was given a first. He gave a first equation for the for the for the antimatter. Is this is antimatter equation is um, he was scribbling these equations, and he was a brilliant man. He's a British physicist. He doesn't he's not he doesn't talk much, but he's brilliant, and he's a genius. So he came up with the equation for the positron, and some of the equations he was doing, and it turned out to be there exists a antimatter exists, and you could not believe himself that equation is suggesting that there exists a antimatter and positron. Um, so he kept it under the rugs for 3 years. He did not say testing and testing, keep on testing about this matter, this thing, and then eventually what he did was he published it. Then, after publishing 5 years after that, it was experimentally verified. Carl Anderson from the University of Berkeley, they found the positron, which is exactly that. You see that in the Wilson chamber, the top one is electron negatively charged, is going opposite was a positron. So they found in the Wilson chamber that is ion chamber, that the water, they found that they experimentally verified after 5 years in 1932. Carl Anderson from University of Berkeley, UCSF, not UCSF, Berkeley University. But what is a positron? PET scanner now came out of that process. PET scanner is a positron emission tomography scanner. It's a huge gantry there. Or you see that big white, people know from, probably you take yourself or your relatives went inside, or not PET scanner, but the MRI, CT scan, they all look same. They're detectors. So the circular things always a detector, that is. So they recently, there was a lady that in Nashville. She gave a by mistake a sedative. A lot of people are claustrophobic inside, and they gave a sedation medication by mistake. She gave a deadly dose for that lady in Vanderbilt, and she died. And that was a big trial, and she was convicted. The nurse was by mistake. She did that. She was convicted. Actually, that's a sad story. but is a truly sad. But so these are what they do is what is the function of the cancer and the tumor. They consume a lot more. They're more active. They consume glucose. Cells need glucose for energy, so they could start consuming a lot of glucose. But you know, so so what they did was this: they give a injection. FDG is called. Fluorodeoxyglucose. That's called deoxyglucose. It means take the glucose and take the oxygen atom out, and then put the fluorine atom, which is a radio tracer. It's a transmitter basically. You know that some people said that during the Trump era, people give a chips inside. Is it possible? This is the chip inside radio transmitter. But it stays in the temporarily there. It's not stays there for a long time like a chip. But this glucose, the cells get deceived by this process. They think they are consuming the glucose, and FDG is a chemically same analog to the glucose. The FDG is analog to the glucose. It is so the body doesn't know the difference between these two. So it consumes it as a glucose. It thinks that the cells think it is a glucose and consumes it. But it has a radionuclide inside, it's transferred inside. It produces the positron inside, and then when the positron comes out, and then it interacts with the electron in our body. Our body is full of, cells contain atoms, atoms contain positrons, neutrons, protons, all of those fundamental particles. So the the positron comes out of the FDG, and then it comes out and interacts with the positron, the electron in the body. Immediately, what it does is it produces a huge burst of energy. Gamma ray is a very strong energy it produces, but it produces a ray. A ray. I show you that it's a detector, ghost ray detector. So, by the way, this is the FDG. Is half life is 2 hours. So they have to make it in a hot lab. So the cardiologists use rubidium 82. Half life is 75 seconds. That's why they buy a generator, a rubidium generator. That's a $30,000 per month actually. FDG, at least you can get it, and two, you have a time for 2 hours. These are the radioactive materials. These FDG highly controlled substances. Um, so this one goes to the when you consume the tumor consumes the FDG. What it does is it produces the positron, and immediately by the law of the conservation of energy, law of conservation of momentum, actually, that follows the Newtonian laws, purely simply Newton's laws of physics. They follow and produces the ray exactly opposite of each other. It goes 180 degrees exact. It doesn't miss. And then by attenuation of the other factors, they measure the detection time, and see that how fast it's coming. Millions of times they produce this thing, and it actually every cell is producing quite a bit of this show. So they detect the show, and mathematically they come back with the with the with the detection mechanism. You see, for example, it's a functional PET scanner is a functional one. It's not a structural. What is the difference between structural and function? Is you don't get the in a functional side. You get only you can only you know only where it's going. Structural is inside. Your cellular structure. You know the exactly more details. That's why they use the PET CT to get the functional and the structural details. So PET scanner won't give you the structural details as much as the PET doesn't give as much as CT scan does. So they combine them together. They do PET CT scanner. So here on the top, this is a human, the 40-year-old woman. You see on the top, the torso, the brain consumes a lot of glucose. So that's a normal. That's nothing. That's not a cancer. Here, it is somewhere the darker it is, it's kind of worries. It is so here in the left side there is a possibility. Here you see on the right side in the fourth quadrant in the right side, there's a circle there on the near the across the heart. That's a lung nodule, possibly lung cancer. Okay, so there is this also in the left side. There is a in the in the liver, kidneys, those kind of. I'm not a radiologist. Don't hold me. But these are all possible tumors and cancers could be. These are the areas it's showing. It's so the great thing about PET scanner can give a explicit details about the cancer progression, cancer things. It does. Then they add they want to look at that. So when they once they point out where it is exactly is going on, then what is the advantage of it? You don't need exploratory surgeries. In 1900s, in the beginning of 1900s, and they used to do a lot of open up and then see what's going on. You don't have to open up anymore. You can do that. Exploratory surgeries are done. We don't have to do that anymore. So you can do the PET scanner can produce that amazing details inside the body. Um, so to use the radio sources, we need to use what do you call? You need to use the radio sources. You have to cyclotron, a simulator produces this kind of a thing. The cyclotron produces the radioactive materials, a fast moving protons, and they collide these things and they produce these radioactive materials. But the problem with that is you need only United States is 150 cyclotrons in the United States. In China, 130. You know, if you see uh, India is only 19. Okay, so we have to go a long way. This is a progressive. If you want to know how a country is progressing, this is a good indicator of how they are taking care of this population. Is 150 versus 19, 1.5 billion people, only 19 they have. So we have to go a long way for that. We need to do some work on this area. So patch scanner is so they use now they have a two different kind of PET scans came in. They can use a PET CT. PET CT is CAT scan is 16 slides, 64 slides, 256 slides. That means a lot of radiation goes through. More you are exposed to, it can cause cancer. Actually, the radiations are. So people go for the cancer. They get exposed to PET CT. They may get a cancer because of the PET CT exposure. So there's a danger to it. So there's a new modality is coming in the picture. It's called PET MRI. It's not too many places there right now. It's a structurally it is a great because the MRI doesn't give radiation. You know, CT scan is X-ray radiation. The MRI is a magnetic radiation. So there is no radiation in the PET MRI. Only thing you don't want to wear any jewelry, anything. If you wear a jewelry, for example, it is a rip off your. If you go to the close to the MRI, it rip off your ear. I can tell you that that magnet is so powerful, it can rip off the ear. So that's why they want to tell you don't wear any jewelry and everything before you go to MRI. So that is the two modalities, or they can detect cancer and tumors very well. They use a lot of powerful mathematics. I spoke before about the entropy mathematics, Shannon entropy. They use it to detect much more progression of that disease, how fast it is going. Those kind of things are going to be the future of these things. That. Let me the so it is a great tribute to this man. He moved to Florida at Tallahassee State University, and then most of his life he lived in England, and then he moved Westminster, and then he moved the last 10 years of his life. His daughter was in Florida at Tallahassee, even though he was offered a position. Einstein called him a genius. Yeah, he was offered in the Princeton position. He didn't take it. He went to Florida State University, Tallahassee, and then eventually he died there very quietly. He's as he was, his personality, he quietly died there. Nobody knows his name. He's an unsung hero of oncology, in my view. So that equation, positron equation, was he played on the tombstone of his in Westminster and also in Florida. So it's a great tribute to a man who gave this life to this positron and then the whole field of medicine. So I'll let you introduce Jennifer Niemeyer, our Vice President of MedBricks. She's going to introduce you the products we have. She can tell you a little bit more. So about it. So let you bring Jennifer. Are you there? Oh, I don't think she is there. I don't know what happened. I thought I saw her. So, but anyway, thank you. You can go to dailywearformedicine.com. You can see you can see the you can see you can purchase these t-shirts, and we have a coffee mugs. You buy an Etsy. So go to www.dailywearformedicine.com. Thank you very much. Bye.